Hi everyone, in this video we will talk on TIA portal. What is TIA portal and what is the difference TIA portal program from other programs? Firstly, let's start with the opening TIA portal version 14. It's opening now. Know that TIA portal is a big program and need take time to open. When we open a TIA portal, the first screen is like this. You know that there are some information. Just here we can open an existing project saved in our computer. In this area we can create a new project, and for this area we can migrate any project, and also in this area, in online diagnostics area, we can see the PLCs or other Siemens available Siemens products connected our network. And this area also is a screen which shows us the last projects we worked on. And this ecran is a portal ecran for TIA portal, and we can pass project view in this area and click. As you see, this area is a project area, but that is no any related informations regarding the PLC or other informations. And in this area we need to open a new project. I click here for new project. You know, in this area we can write our the project name. For example, and we open a project area. You know that our project is open, TIA portal version 2, and in this area we can add a new device. I click new device, and you know that in the new device screen there are three parts, three area, three section. You know, in the section controller, which is show us the controller CPU schematics S7 1200 and others. In this area HMI screen, and this area for the SCADA stations systems. And we will work on the PLC's CPUs, and in this area we choose a CPU. You know that in this video we will work on S7 1200. Also, you know that there are many types of the CPU, and we can choose any one and available for our project. And for example, I will choose this one, sorry, this one, CPU 1214 DC, and this guy is available for me. I know this PLC, and in our factory I have worked with this CPU, and I know this CPU type, so I will show you our examples on this video, on this CPU. In this area, you know that you can read, you can see the all informations you checked here, and you know that we can see work memory and power supply voltage and the number of input output, the type, sink or source, also other informations related to this PLC. You can see just here, and if this information is eligible for your project, you can choose this CPU. If not, you can choose another CPUs, and you can see all informations in this area. I will choose this CPU and I click OK. As we said, the portal program is a huge program, and your computers need a good good specials. And you know that we see our CPU on the screen, and if we need more IO, we can add just here. You know that, for example, we can add any input like here, know that, and blah, blah, blah. And we can add any output model here. This is just simple, and we can compile it. First we need to choose PLC, then compile. It is compiling. And now we can pass the program blocks. In this area, you see that there are many specials for TIA Portal to manage the programs and to manage the PLC and PLC related issues. There are many special to help us to write any code to manage all the process. I will show you in next videos in details, but today we will check it. We will check with a summary way. And first we will open main block. You know, in this area, this OB1 block is a main block of the TIA Portal. All blocks that we will see later will connect this block and will communicate with CPU on this block. I will show you in next videos with details. And another parts we need to see today is a PLC tags. In this area we can see our tags here. When we create any text here, this text will transfer to show to default tag table automatically, and we can see we can follow all the text just here. And I'm opening now. In this area, you know that this section is empty. When we write here the codes, we'll see that all the text informations will be transferred just here. And As we said, the block of main or V1 is a main block, and all the other sub blocks connect to main block, and the communication with CPU made via main OB1 blocks. We will show all that issues later with a details way. Now we will understand. We are trying to understand the TIA portal briefly, and in the other videos I will show you all details for all functions. For each function I will show the all details we need to know. And now let's try make a simple program, and let's think that we have a motor, a start button, a stop button, and we want to work this motor via start and stop button. Firstly, we need to add a normally open contact for the start button, and we will need a stop button, and last we scroll a coin here. Sorry, I will show you this function later, but now I will delete. Oops. And coin just here, and I write the address. Firstly, I will give a physical address, begins with input 0.0, and let's change the name. Start, and this guy also needs a physical address, and input 0.1, and let's change the name also, and stop. This guy will be motor, and we will address a output address, and that output address begin with q 0.0, and the name motor. I used this address before, and you see the name now. So let's write with a simulator. First, let me compile it, and that block was successfully compiled, and there is no error or warnings. As you know, the program is simple. There is a start button, there is a stop button, and there is a motor. When we activate the start button, this motor will work, and when we deactivate the start button, also this motor will be deactivated. Also, while working, when we pressed stop button, that is not possible to work this motor, because the stop button is activated. Let's try it with a simulation program. Start simulation. That there is a warning. I cannot make with this CPU, and I will try with the higher PLC. Okay, and let me copy this program. Copy. I will add another device, and now I will work with the CPU 1500. Let me check it. Yes, this is good for me because you know there are ready input output. Okay, let's compile. So there are no problems for compiling. And you know that now we have two CPU. This one is 1200. Also, this one is a 1500 type. We changed the type of PLC CPU because we couldn't make the simulation program with this 1200 CPU, and we will try it with the 1500 now. Let's open a block, and the main block is the same. Let's paste. No, that is not possible to paste this. I will make that program also in this block. You know that it's the simple. The for start button, this is for stop button, and this is for the motor. Let's set the address again. Input 0.0, input 0.1, also Q 0.0. You know that all these address are physical address. In PLC CPUs, in PLC sector, in the Siemens group, the number of the name of the address of the inputs begin with E input, I, and output address begin with the Q. You know that input 0.0, the first 0 is the byte address, and the second 0 is the bit address. Also, you know that 0 byte, 0 bit, 0 byte, 1 bit. Also, the issue is real for the output, the 0 byte and 0 bit. Let's change the name with start, change, and stop. Let's change the name of the output as motor. And you know that the program is ready. We have a start button and one stop button and a motor. And let's try it with the simulation. It's opening now. Okay, and our simulation program also is ready. As we see, it's just here, and let's monitor it. And you know that the stop button is active, start button not active, also motor not active, because if we activate is the work motor, we need to activate start button. Let's try it with modify. You know that motor is activated and working now, and by deactivated start button, motor is deactivated, as you see. Also, I again made the start activate, and you know that the motor output is active, and when I activate the start button, you know that also motor is deactivated. Okay. Also, for this area we can make a sealing here with a parallel button, and let's add a open contact, and the address is the same with the motor. When we press M, you know, we can see this motor here. It's simple, and we can make with this way a sealing process. You know that. So let's download it. Okay. Yes. You know that top button is active. Also start button is active. I will deactivate both of them. Also, yes. Yes. The conditions is like the beginning. You know that we have a start button, we have a parallel button belongs to motor which will make the sealing. Also the stop button is ready. When we activate start button, you know that motor is working now, motor is active now. Also you know that this motor can take its energy on this contact. Also we deactivate start button, you know, motor is working now. So in this process, in this time, we don't need the start button, because we make seal with a motor's button. You know, if we want to deactivate the motor, we need to activate the stop button. Oops, you know that we change the position now. Also we deactivate also stop button. You know, if you want to activate this motor output, you need to activate also that button. You know that program is simple. Also we can make this issue with a set or reset functions, and it is a good and eligible functions in PLC in normal conditions. Set and reset functions being used frequently, and let's try it with it. Oops. We add an that button again, and get a coin. Also, this is another input 0 1 2. This is already, you know, that 0.0 0.1 0.2 until 0.7. It equals to 8, the number of bits. And let me change the name. That 2. Okay. And another output to 0.1. Sorry. And the name of the number of the address of the another motor is Q01, sorry, Q0.1. And let's rename the as motor 2. Okay, but we need to change the special of this function. You know, this function as working as coin. This function is for setting this function for to reset, and we will use the set function. And you know that when we activate the input 0.2 start to this motor will be set, will be activated. But if we want to reset, we need to add another function like this. Work and open contact again. Also we add a coin, physical address input 0.3 now, .2.3, and let's change the name stop 2. Let's go on with the reset again. Q0.1. Yes, as you see, it's the same motor 2 Q0.1, Q0.1, and with this ladder we will set the motor, and with this ladder we will reset the motor. Let's try it in a simulation. First, I will download it. Good. I think there is a problem. So the first block was changed. Okay. Problem. Now, as we see, we have two parts waiting for working, and when we start here, you know that motor is working now, and if this section is 0, the status is continuing. Motor is working now, not stopped. Also in this area we will set the motor. Sorry, you know that motor 2 also is working. If I change the position also, you know that the set position is stable and the working process is continuing. And if we want to reset this motor 2, I need to activate stop button. You see that motor 2 is not activated and is stopped, as you see. And I will change the position 0 again. And if I want to stop this, I will activate this one, and you see that this motor also is not activated now. Position is the 0 now. As you see, my friend, this PLC process, the portal process, is not hard. It is simple. Just we need to make more practice on this program, and the portal program is very good and helping us to manage the problems, to solve the problems. So this video just for the briefly explaining, and in the future videos we will work on another functions, another libraries, and we are going to try understand all the portal and PLC process. I think it is enough. As you see, this is a simple, and this is a simple program, and working like this. Just we need to more examples using all these functions, all those elements. In the next video we will make more some more additional functions. We will work with that. I think it will be very useful for us. Thank you for watching. See you next video.